Okay, quick question. If you had to pick the single most perfect predator on Earth, who are you picking? Lion? Eagle? Shark? Got your answer locked in? Here's the plot twist. Nature already built hunters way more efficient than any of those. And every single one is smaller than your palm. You're standing by a pond at dusk. A dragonfly drops out of nowhere, hovers an inch from your shoulder, then just vanishes in a blur. A second later it's back, floating in the exact same spot. The mosquito is gone. Caught, done, somewhere between one blink and the next. You didn't even see it happen. So here's the question that's actually going to bug you. How does something with a brain smaller than a grain of rice never miss? Your first guess is probably speed, right? Faster wings, faster reflexes, faster strike. Makes sense. Missing always feels like being too slow. But speed isn't the trick nature keeps reaching for. The real answer is weirder than that, and it shows up in three of the smallest, strangest hunters on the planet. Paloma Gonzalez-Bellido at the Genelia Research Campus, part of the Howard Hughes Medical Institute, ran a study published in the Proceedings of the National Academy of Sciences in 2012. Her team recorded from just 16 neurons inside a dragonfly's brain. 16. That's it. These neurons, called target-selective descending neurons, don't just track where prey currently is, they calculate where it's going to be next, turning that into a signal so precise it steers the dragonfly's wings toward a point in space the prey hasn't even reached yet. The dragonfly isn't chasing that mosquito, it's meeting it there. Wild, right? But here's where it gets even more interesting. Watch how differently each hunter solves the exact same problem, depending entirely on where it's fighting. First up, the dragonfly, doing its thing in the one arena where nothing ever holds still. Open air, 3 dimensions, 0 walls, 0 cover. It catches prey mid-flight with a success rate near 95%. Before it even moves, it locks the target onto a high-resolution patch of its eye, then mid-chase it predicts where that path is heading instead of just following it. In open air, prediction is basically the only strategy fast enough to work. Makes sense, right? Second, the praying mantis. Totally different battlefield, a single still leaf, where the real challenge isn't speed, it's distance. How do you know exactly how far away something is? Jenny Reed at Newcastle University, publishing in Scientific Reports in 2016, did something almost ridiculous to find out. She built a tiny 3D cinema for insects, complete with miniature 3D glasses glued onto a mantis's head. I know, but it worked. She found mantises use stereopsis, real depth perception from combining 2 slightly different images, one from each eye, exactly like your own eyes do. A mantis doesn't need to predict a moving target. It needs one perfect number, the exact distance to something that thinks it's safe just sitting there. Third, the assassin bug. Fighting in the tightest, most brutal arena of all, pressed right up against its prey with 0 room to react if the first move goes wrong. Andrew Walker, at the University of Queensland, publishing in Nature Communications in 2018, discovered this bug carries 2 completely separate venom glands. One is built purely to hunt, instantly paralyzing and liquefying prey the second its beak makes contact. The other is a totally different venom, used only for self-defense. An assassin bug isn't outflying anything, and it's not calculating distance from afar. At point-blank range, all that matters is a strike so total the fight is basically over before it starts. So here's the twist that should mess with your head a little. A dragonfly, a mantis, and an assassin bug share almost nothing. Different eyes, different weapons, not even the same body plan, and none of them would survive using each other's strategy. Try the dragonfly's predictive flight path pressed against a beetle at 0 distance? Useless. Try the assassin bug's venom on something zooming through open sky? Also useless. There's no universal winning move here. There are 3 completely different answers, each one shaped entirely by the space that hunter has to fight in. Okay, but why does any of this matter to you? Because you've probably spent time wishing you were just better, faster, sharper, more decisive, like there's one ideal version of you waiting to be unlocked. But the traits that make you great in one part of your life, quick improvising in a crisis, patient thinking before a big decision, going all in when a moment demands it, are rarely the same traits. And using the wrong one in the wrong moment fails the exact same way an assassin bug would fail chasing something through open sky. So next time you feel like you're just not good enough at something, Try asking a better question. Not, how do I get faster or stronger at everything? Ask what arena you're actually in right now, and whether the strategy you're using was ever built for it. Nature never built one perfect hunter. It built a dragonfly for open sky, a mantis for a single still leaf, and an assassin bug for point-blank range, each one unbeatable exactly where it belongs, and completely helpless everywhere else. Maybe that's you too. So, what arena are you actually in right now?